Thank you. Thank you so much. Dobro jutro, Belgrade. I'm surprised that people are here that early, but I'm here too, so let's get it started. So my name is Simon. I'm a developer relations engineer at Edge and Node, working for the Graph. And in this next 30 minutes, we talk about what's next for the Graph. But before we start, we quickly check what is the Graph today. So in a nutshell, the Graph is this. We have a mess of data, a lot of data on blockchains, and the Graph kind of magically brings that in order so that we can then query it and use it. Isn't that nice? Or a little bit more from a technical level. Initially, the idea was that we have fully decentralized frontends. They are from IPFS, and people run their own blockchain nodes on their computer so they can interact directly with the blockchain. There's an interface called JSON RPC, but that has a lot of problems. So nowadays, nobody runs a blockchain anymore on their computer, or very seldom. And also, the whole blockchain is incentivized for data writing, right? So we pay the validators some money if you want to write data to the blockchain. But if you want to read data from the blockchain, there is no real incentivization in the protocol. So that leads to the problem that data reading from the blockchain is slow or hard. So there's also the JSON RPC interface that is not really made for this. We will go a little bit deeper into that. So now with the Graph, we have this thing that the Graph sits in between the front end and the blockchain, and so-called as a data layer. So we say the Graph is the data layer for Web3. So we have data from the contracts indexed so that we can quickly serve it via GraphQL to front ends or other data science applications. As I said, the data layer of Web3. So more in a nerd speak talk, I would say, before we had this query, so with JSON RPC, we need to always send this query to the endpoint. It goes 200 milliseconds, and then when we just do a simple thing like displaying all tokens that somebody has in their wallet, then this person has maybe 10 or 20 tokens. This code takes up to minutes to resolve. And I mean, nowadays, people, after half a second, 1, 2, 3 seconds in Web3, we're a little bit used of waiting, right? With UX, people leave and think that doesn't work. So the Graph, with GraphQL, we can have one simple query that resolves in 100 to 200 milliseconds, and we have, boom, all the tokens that someone has. And that all works in a decentralized network. So as of now, or yesterday when I last updated the slides, we had 331 indexes. There are individuals across the world that are there to serve the data that we need in our front ends. And then there are other participants like the delegators, easy way to get to interact with the Graph protocol, the curators, and also more than 1,000 subgraphs now deployed to the decentralized Graph network. So that's a huge step. Also recently, or since we launched the decentralized network, it also improved on query performance. So we see query success rate is 99.97%. It's better than the hosted service, the service that we were running as a proof of concept before. Also, the indexes are able to give quicker responses. Median latency and average latency is much better. And up to now, there were 2.25 million query fees collected on the decentralized Graph network. So we have now this possibility to have truly decentralized apps, or dApps, right? And a lot of projects already migrated to the decentralized network, from them Premia, SushiSwap, Artblocks, and NFTX, and some more. So really people are seeing the value of the decentralized network and migrating it and really want to have this decentralized data stack. Also, there was the Graph protocol initially, or the smart contracts were on Ethereum layer 1, obviously a little bit high gas fees, and now there is this scaling to L2, to Arbitrum 1 in progress. And just recently, the indexing rewards are enabled on Arbitrum 1. So some of the subgraphs and indexes are now on Arbitrum 1. The whole protocol is cross-chain, so it communicates with each other. Very interesting for those that want to see into this. All open source and documented. If you are into these cross-chain protocol communications, check it out. And on the decentralized network, there are also like 7 chains like Gnosis, Arbitrum, Polygon, Avalanche, Celo, Phantom, Ethereum mainnet, and more to come, right? So that's really happening right now. So this is the point. Like there's a decentralized network. The graph has a crucial stack in depth. But what's next? So the graph has a big R&D team, and it is mainly in these 5 different research areas. So it's data and APIs, indexer experience, protocol network and operations, a SNARK force, a dedicated SNARK research team, and then the protocol economics. And these research areas are kind of these 6 teams or core devs working on these research areas. So we have Edge and Node, the one that I work for. Then we have Streaming Fast, that does Substream and Firehose, we jump into this. GraphOps, indexer tooling, and Semiotic is this research group that is cryptography and blockchain research group. Then the Guild, front-end, open source, OGs, and then Messari as the ones that are creating the high-quality subgraphs. We jump into all of them quickly. And then also like how the graph defines success. So the graph network aims to have like the best quality of service, the best cost of service, and the best developer experience. This is the roadmap, or like the North Star. So let's jump quickly into substreams. The recent addition by Streaming Fast. There was a lot of talks about substreams recently on Twitter around from the graph ecosystem, but I would like to quickly explain how this works. So when we look at subgraphs, basically we can talk about, or we can see this as ETLQ, so a very software engineering term. Quickly explained, it's like extract, transform, load, and then query. Extract, currently it's made with JSON RPC. With polling. So JSON RPC is a very low-level protocol that is not especially made for fast data extraction. Then we have the assembly script that compiles down to WebAssembly. We do the transform. So the data that's extracted is transformed in a way that we later can load it into the database. It's a Postgres database. And then finally query it with GraphQL. So this is how subgraphs currently work. And also a lot of other indexer tooling that is around out there is usually the same ETLQ process. Now, the first component that was evaluated was the extract part. So JSON RPC, as I said, has some problems. So mainly, when we think about the blockchain as a whole, JSON RPC, in my opinion, is kind of, I go there with a pin set and I say like, oh, I want to have like this block, or I want to have like this transaction, I want to see what's in there. And that's not suitable for fast data extraction as we want to see it today with this new use case. It's good enough to maybe say, oh, I want to send a transaction, I want to see when this transaction was mined, but not really to have like a big analysis of data. So that's where actually Firehose comes in. You know, and instead of this pin set, we just have like this stream of raw blockchain data that goes directly out from the nodes into flat files, fully typed with proto-buffers, and that we can easily start to parallelize and stream out. So this is the Firehose, right, the extract part. And the Firehose is battle tested. Like it runs on the Graph's hosted service where we serve 1 to 2 billion queries per day currently. So the Firehose is really production-ready data extraction fast protocol that we can use. And it's all fully open source, so check it out. Then the next part that Streaming Fast starts to look at is, what do we do now? From the Firehose, we have this raw, full stream of blockchain data. What do we do with that data? We need to refine it, because like there's so much data, we only need to have something, right? When we say, for example, we want to see a price, a token price, how it develops, then we only need exactly the swaps on all the dexes when this token is swapped in order to have this price feed. And that's what substreams basically do. It's like taking the data and refine it with modules that we can run in parallel, and also like increase then the speed. And in the end, we have like transformed streams of data. So that comes up with this comparison. So we have on top the traditional subgraphs, and on the bottom Firehose and substreams. And what's important here to know is like firehose and substreams, they only are the extract and transform part. And that's also why like there's a lot of talk about substreams powered subgraphs, because that setup is like we have the firehose, the substreams, and then that is fed into a Postgres database, and we have the same GraphQL query interface as with subgraphs. So this is already ongoing. The Uniswap v3 subgraph was rebuilt completely by streaming fast with substreams, and it's already on the decentralized network and can be queried. And that's roughly how it looks like. We have the full blocks that come in on the top. And then, as I said, like if you want to have the price, then we can go in all the dexes. Each dex has its own module, and in the end, they will all be combined, and we end up with like average price stream. And the cool thing about these modules is they are modular. That's why we call it modules, right? And then we can use that that price stream and combine it with OpenSea NFT sales, and then in the end, we have like this volume per collection. And also important to note on this slide is each color represents a different author or engineer. So like now we can even start to collaborate more, and people can start to work on like specialized modules and then in the end combine them together. So that's a very beautiful architecture that is rolling out right now. So if you want to try out substreams, there's also information on the graph. On the graph.com/docs, we have now substreams. Yeah, we can parallelize the whole thing, and that's a good thing. So through that parallelization, we saw up to 100x indexing speed improvement. So, for example, the Uniswap v3 subgraph, it needed roughly 2 months to sync from when it was deployed to now. And with substreams, they were able to do this in 20 hours, like without any cached data. The cool thing about substreams is also like the submodules can also be cached, so like subsequent changes don't need to re-index fully as we had it with subgraphs. All right. First, I need to drink, and then we talk about the chain data from Messari. So Messari is a household name, I would say, in Web3 or in crypto in general, as this business intelligence company. They started early on to bring transparency to the space, and so they are on a very good mission in that regard. The mission aligns in a way that they say, together with the graph, like when we want to create the transparency, then the data needs to be transparent too. And they started to look at all these different protocols and all the different chains, and had these metrics, right? We can all these protocols. Here we see the lending ones, so we can categorize them. So we have TVL, revenue, deposits, withdrawals, borrows, repayments, liquidations, maybe more. And there are different data sources out there. So data source A is very good in TVL. Data source B has a little bit more, but is also less complete. And then we have a data source C that's even like has other priorities. And then in the end, if you want to combine it, we have sometimes still holes in the whole analysis of data that we want to see, but also sometimes conflicting information. So when I have from the same, like for the same metric, different data sources, so which one is then true? And like interestingly also, oftentimes these data sources were even disagreeing. So like the one data source A says this number, data source B says this number, so what's true and what's TVL actually, how can we bring that? And so they set out to create data sets that are really unified across all these different protocols that are open source and that we can use. So it's now very easy to compare between these different protocols, these metrics. There are the Messari data apps that we can see on the Messari website, and also, so we can create these dashboards, right, where we can compare different lending protocols with each other, easily with click and drop, because also underlying, they have all the same GraphQL interface, the same schema, and so we can easily build our own stuff on top. Like not only Messari, these subgraphs are open for everybody to query, and we can now build our own dashboards or our own intelligence stuff on top of it. Yeah, more examples. a similar slide. So like as the same as I said before applies for the Messari stuff. We have on top the protocol metrics UI or the usage of the subgraphs of the blockchain data. Then we have the graphs with subgraphs in the middle, and on the bottom like the contracts and the blockchain. So yeah, there's the protocol metrics website is cool. It's all powered by data from the graph. Check it out. It's very easy to navigate and see what's going on in these different protocols. Yes, then we have the Guild. The Guild also joined as a core dev team. The Guild is basically well known in the GraphQL community, very open source focused a group of people that joined the graph to really build the best GraphQL interfaces and the tooling around to create a graph. And one of these tools I quickly want to see, that's the Graph Client. So the Graph Client can sit on top of the front end and the graph and make it more convenient. So for example, like having multiple, like usually a lot of these dApps are deployed on different chains, and then they have like different subgraphs that feed into it, and with the Graph Client, there is an easy way to combine this all together. And also very nice helpers. So for example, we can have live queries or block tracking, so we always know like which is the latest block, and cool stuff. So if you're a front-end engineer, make sure to check out Graph Client. It's a very convenient tool. Then we also have the GraphOps. So GraphOps is a team that is focused on indexer tooling, and they have basically made they're working on two products. The one is the Launchpad. So the idea is to have like a Kubernetes Helm chart or configuration to quickly launch an indexer, so that should be as easy as possible to become an indexer on the Graph network. And then also GraphCast, which is this idea of a gossip network between the indexers. So indexers by itself somehow are competing with each other, but also have like incentives to collaborate with each other. So that's where GraphCast comes in, kind of an idea that indexers can with a gossip network share some information with each other, and it all builds on Waku. That's a gossip protocol, I think, from Ethereum nearby dev team. So very cool, but like this image just shows like basically GraphCast sits on top of this giant, which is basically Waku. And then one core dev team is Semiotic. They are in Los Altos, and this is really a focused team that has like these three pillars of research. It's a research team. They look into artificial intelligence, cryptography, and verifiable computing, and then general software engineering. So verifiable computing for the graph is an important topic, because the idea is when I send a query to the graph network, how can I be sure like that the response is actually correct? In order, like the end goal is basically to have verifiable queries, but that needs to have verifiable computing actually through the whole stack, like from blockchain extraction to indexing to querying. And Semiotic is really focused on this. So I think the first projects are like verifiable payments. So that's one of the ideas of having more security when gateways pay the indexer, that there is less trust. And then verifiable indexing, so that we know, like as consumers of the graph network, like okay, the indexers that index something, they actually saw the right data. Then there is a lot of also snark research to make this stuff more efficient, but I have to admit, like I'm not very familiar with the mathematics behind snarks. I'm happy that I understand private and public key cryptography. And finally, verifiable queries, as I said, are kind of like the end boss in this research category. Also, it's funny for those that know a little bit about cryptography research. So they were kind of going around this land of cryptography and different approaches like Starks and Snarks and Quarks and Plonks, and then ended up with the homomorphic signatures. There is a talk from Jackson from DEF CON that's more interesting, that really goes into how they approach the problem and where they stand, if you're into this cryptography research. Also, semiotic works on AI. So one of the AI components in the graph is this so-called auto-modeling of indexers. So they kind of know or find out which is the best price for the queries that I as an indexer should set. And they started with modeling the whole thing out, and I think now it's also starting to roll out the indexes that the price discovery do more or less automatic. Yeah, putting it all together, so we see like we have the data APIs, the indexer experience, the protocol network operations, snark force, and protocol economics. Then these are the research groups, and then we have network multi-chain support, Firehose, substreams, graph client, graphcast, integer launchpad, Messari subgraph, scalar payments, AutoAgora, verifiable queries, and so much more. So there's so much going on within the graph. It's so excited to work alongside these all super smart people. And in the end, the goal is like harder, better, faster, stronger. Like harder trust guarantees, better developer experience, faster query processing, and stronger uptime guarantees. Whew. So I know that was a lot, but like when you scan this QR code, you will end up actually to have these slides. They're public on the Google Slides, and then you can like also go through by yourself, maybe later, and go through all these topics. There are some descriptions in the footnotes for each slide. But yeah, feel free to scan the QR code. You can also click on my face on the first slide and get to my Twitter if you want. But yeah, thank you so much for your time, and thanks for having me. Have a great Sunday.
So, yes, we have a question from the audience. Can we get them? Oh, second.
Hello, thank you for your talk. The graph is an amazing project, and really I like it very well. So let me start with a short story. So first time I tried to use graph, maybe in January and February, I used Ava subgraph, and after like struggling, after a couple of weeks of struggling, I found out that the data is completely incorrect. So their subgraph, literally, they showed like wrong balances. They didn't include interests, etc., etc. So, like, for instance, if I want to use the graph data, how I can distinguish the like subgraphs that are not anymore supported from subgraphs which are actually doing very well? So,
yeah, that's a very good question. So I would start with the Messari subgraphs always, because they are well maintained. Basically, it's a permissionless system, so everybody can just deploy a subgraph. So like the quality assurance is not always guaranteed. On the decentralized network, there is also curation. So subgraphs with higher curation have like higher chances of being high quality. But I would really start with the Messari subgraphs and go there. And then to know if the data is correct that you get from an indexer, on the decentralized network, they all send so-called query attestation in the response headers. And there are fishermen, and you also can become a fisherman when you think like that response is actually wrong, then there's possibility to open up a dispute against that index, or maybe they get slashed for some part. But TLDR, go with the Messari subgraphs.
Does that answer your question? We have another question in the front row.
Thank you, Simon, for your speech. It was amazing to hear and see from you on your slides that moving towards from the hosted solution to the derived solution actually improve all those metrics like uptime, reliability, latency, which may be not so obvious, but in case if it's true, it's amazing. However, probably you know that some centralized data provider also utilize agent-node open source software to run subgraphs as a hosted solution, as a centralized solution like Satsuma or Goldsky or Chainstack. So my question, what is opinion of agent-node in the graph team regarding all those centralized data provider? Are they helping your ecosystem or they kind of competing with you?
So I would say all of these centralized providers, like I give them a very good advice, join the decentralized network as an indexer. Other than that, I mean, like what we build is open source, and we believe that the decentralized network is the best choice. But with open source, I would also say, like in the end, people can choose by themselves what they think is the best solution.
Okay, thank you.
Do we have another question? Don't be shy, guys.
Thank you so much for having me. Have fun.